Alright, so I think this is recording. I have a lot of difficulty with starting these videos. Alright, here they're giving me an equation and they're asking me to solve this equation. We want to find the values of the variable that will make this a true statement. When you substitute in the known value for x, then you do that arithmetic on the left hand side, it tells us on the right hand side that that result should be 32. So we need that to be a true statement. So step by step, we need to get this variable x by itself. That's the goal. And in our toolbox to do that, we have our properties of equality that allow us to balance this equation. But we have a little bit of a difficulty when our variable is in an exponent. So for these problems right now, we're going to be able to rewrite the base so that we have the same base. So right now, we need to play around a little bit with the numbers 64 and 8. How can we rewrite the number 64? Well, what immediately jumps out to me is that 64 is equal to 8 squared. All right, so I already have an 8 down here, so that's at least the route that I'm going to think initially. Let's see if this gets us anything, and maybe if it doesn't, we'd have to start over. So I've got 64. And it's being raised to the 3x power. I'm going to rewrite the 64 as 8 squared. Now down here I already have an 8, and that's being raised to 3x power. On the right hand side I have 32. So in the numerator here I have a power to a power, and our properties of exponents tell us to multiply these exponents. So 2 times 3x is 6x. I have division. I have this 8 to the 6x being divided by 8 to the 3x. I can write this with a single base if I take this exponent that's in the numerator and I subtract from it the exponent that's in the denominator. Alright, so we are accomplishing something. This equation is becoming less complicated. It was a fraction, and now it's not even a fraction anymore. And we have this 8. And 6x take away 3x is 3x. But we have a problem here. I need these numbers to have the same base. Okay, it worked out fine on the left-hand side when I rewrote with a power of 8, but now I can't rewrite 32 as a power of 8. So how can we rewrite 8? Well, one way that we can rewrite 8 is 2 to the 3rd power. And this 32 doesn't take long for you to play around with multiplying by powers of 2 to recognize that 32 is 2 to the 5th power. So that's just telling me that initially when I chose 8 that I could have looked at it more in depth and chose a 2. But right now I'm fine. This 8, I'm going to rewrite 8 as 2 to the 3rd power. And I'm going to rewrite 32 as 2 to the 5th power. So on the right hand side, this exponent 5 has a base of 2, but on the left hand side, this 3x has a base of 8 still, of 2 cubed. I need to multiply these exponents together. 3 times 3x is 9x, so this base of 2, now has an exponent of 9x. This base of 2 has an exponent of 5. Since these exponential functions are one-to-one functions, if the numbers are the same and the base is the same, the exponents have to be the same. 9x has to be representing the number 5. Otherwise, this original equation that has now shrunk so small that we can't see it would not be true. If I divide both sides by 9, be careful, don't divide both sides by 5. You have to get the x by itself. So it's the factor, you divide both sides by 9 to cancel that factor. So here is my final answer, that x is equal to 5 over 9, and I hope that helps, and I'll talk to you later.